Hello everyone and welcome back to your piano lesson. If you are here for the first time, I am Gianluca Fronda, your virtual piano teacher. If you want to discover interesting facts about me, you can watch the introduction video of this channel. I'm leaving the link in the description of this video, where you will find also the link for my artistic channel, Gianluca Fronda, pianist and composer, if you're interested in original music and covers. Talking about this channel, don't forget to subscribe and let me know about yourself by commenting. Tell me when you have started, if you're finding my channel interesting and you're improving your skills also thanks to my videos. And don't forget also to share with your friends if there is anybody interested in piano music, anybody that you know. So now time to go to our lesson. Welcome to the 18th music theory lesson. Today I want to talk about three topics. They've kind of already been discussed, but I want to clarify and spot in this lesson. I want to talk about all the possible rhythms that you can face and you can get using semiquavers. So all the possible combinations of semiquavers and obviously quavers. Then we will talk about the difference between the 3/4 and the 6/8 and the difference in between the triplet and the duplet. But let's start from all the rhythms using semiquavers. I should obviously suggest you to watch first of all the first tutorial where I explained the semiquavers. I'm leaving always the link of the playlist where you will find all the videos published until today, but I'm also leaving exactly the link where you will get the lesson where I was talking about the semiquavers, plus one where I've been talking about the triplets, and also those where I explained the compound time signatures, comparing them with simple times. Anyways, let's start from the rhythms using semiquavers. I want to draw again that pyramid that I used when explaining the semiquavers. So, obviously I will be starting from the crotchet, from the one count note, to make it simple, because you should know already everything about all the other values, the previous ones, the half note or minim and the semi-breve or whole note. So, from one count you get the two half count notes, that as you know they can be joined, but this is something that should be now finally clear. And obviously each quaver can be divided in two semiquavers. Now, after drawing the 4 semiquavers, one thing that is really, after many years teaching, I noticed that it's something that has to be really re-explained billions of times, because I noticed that also my students have problems. Obviously it's due to the lack of time, lack of practice, lack of dedication. You have to really spend time, guys, trying to solve these problems, because this discipline is not that easy. Anyways, so this is obviously the general case where you get 4 semiquavers, yeah? And you know that I like to suggest to consider the first one like the one where the first note of the quadruplet of semiquavers where you use the number. Could be 1, could be 2, 3 or 4. Here we say, for example, A, and let's use the et. Then here we say and then here again the A. 1A and A, 2A and A, 3A and A, 4A and A potentially. Now, let's try to see which ones are all the possible cases after this one, after this very basic one. One could be, for example, the one where you have one long dotted quaver and, let me make it very long in this way, there is no way that you can get confused, and completed by a semiquaver. So this is a semiquaver, yeah? You see? So dotted quaver, this is a note, and this is a semiquaver. So in this case, obviously, you have two options. Either you do 1A and A, 1A and 1A and A. This one is getting 3 elements, is getting this and this. These 3 are here. This one is taking all of them. Because obviously the quaver is hiding 2 semiquavers, the single quaver. The dot is adding half of it, that in this case is a semiquaver, isn't it? And this one obviously is going to complete, so this one will be 1A and A, 1A and A, 2A and A, 3A and A, 4A and A, whichever is the count where it goes. Or another option could be the one of counting 1 and A, 1 and A, 2 and A, 3 and A, 4 and A. But what am I doing? You see that this number is longer than it was before when I was counting 1A and A, because I am omitting the A. In this way, anyways, I respect the length of the first half. I pronounce the and, not doing anything on the keyboard, and playing here. I show you in practice. Let's imagine that I have, for example, middle C, dotted quaver, and a D semiquaver. Exactly this case. So I have two options. I can do either 1A and A, 2A and A, 3A and A, 4A and A. You see, 3 elements to the C and 1 to the D. 1A and A, 2A and A, and then so on. Or, as I mentioned, I can count 1 and A, 2 and A, 3 and A, 4 and A. But you have to be careful that the length of the number is anyways twice the length of each element. Now you know that the real beat, the pulse in your mind has to be the one of semiquaver. Okay, so I know that many times it's definitely easier if you count in this way, the one giving 3, let's say, elements to the first and just 1 to the last. Otherwise, if you're quite advanced, you can stick to the normal binary subdivision and subdivide even more, furthermore, the last half, simply pronouncing the and playing on the A, like doing 1 and A, 2 and A, 3 and A, 4 and A, 1 and A, 2 and A. Look at my hand. 1 and A, 2 and A, 3 and A, 4 and A. Anyways. Now, one more possible combination of notes. The one where we invert this rhythm, where we have 1 semiquaver here and 1 dotted quaver here. It's very easy to be understood that in this case the first one is the one getting just 1 and this one is getting 3 of them. You see, starting from here. You play on the A straight after the number. You do 1A and A, 2A and A, 3A and A, 4A and A. If we want to use an example using the same identical notes, we do C, we do C, D. And the D is a dotted quaver, C semiquaver, and D dotted quaver. Okay, so it will definitely be 1A and A, 2A and A, 3A and A, 4A and A, 1A and A, 2A and A, 3A and A, 3A and A, 4A and A. In practice, you have 1A and A, 2A and A, 3A and A, 4A and A. Or, also in this case, you can do the same identical thing. You can do 3A and then stop, and you don't say anything, but respecting anyways the length of the second half of the count. You can do 1A and, 2A and, 3A and, 4A and, 1A and. You see that anyways I tap this one. 1A and, 2A and, 3A and, 4A and. It's important you play on the first and on the second. Another combination could be that this one is definitely easier. Could be the one where you get, for example, 1 quaver and 2 semiquavers. Here we are. This is very simple. The first one is, according also to the previous stage, so the first one is the quaver that you see, and these two are nothing else than these two expressed. So it's 1A and A, 1A and A, 2A and A, 3A and A, 4A and A. Or if you are advanced, you can do 1 and A, 2 and A, 3 and A, 4 and A. But the length of these has to be twice the length of each of them. Okay? In a practical way, using now obviously I have to add some extra note. For example, I can do C, D, C, it will be 1A and A, 2A and A, 3A and A, 4A and A. I like to give you all the examples on all the possible counts in a 4/4, for example. Yeah, have you noticed the first one was twice the length of each of the following two semiquavers. Another example is the opposite, where you have the two semiquavers at the beginning and one quaver at the end. Very easy also this one. You do 1A and A, 2A and A, 3A and A, 4A and A. Or even is possible also this one. Remember that anyways you have to keep the length. So the length of the last note has to be twice the one of each of the previous ones. You can do 1A and, 2A and, 3A and, 4A and. Well, anyways, in your mind you tap also the last hidden semiquaver. 1A and, 2A and, 3A and, 4A and. Okay? In a practical way would be like inverting this one, yeah? We can do C, D, C. Two semiquavers and one quaver. Like 1A and A, 2A and A, 3A and A, 4A and A. And the very last example, the very last rhythm that you can get is the one where you have, is the one that I explained as a syncopation, where you have one semiquaver at the beginning, one quaver starting on the second one, yeah, always refer to this 4, yeah? And the last one is here. I'm leaving all this space to simply recall the third one. Chick, chick, and voila. So we have one semiquaver, one quaver, one semiquaver. Here it is, 1A and A, 2A and A, 3A and A, 4A and A. You play on number, on A, you hold on the end, and you play again on the last A. In practice, for example, using again the same identical notes, it will be it will be 1A and A, 2A and A, 3A and A, 4A and A, 1A and A, 2A and A, 3A and A, 4A and A. I think that more clear than this it's impossible. So obviously I will send to all my students this lesson, finally hoping that everybody will understand how to solve the rhythms featuring semiquavers, quavers and semiquavers, and so on, and obviously dotted quavers. Okay, so now after this, the first topic, we have to talk about the difference in between the 3/4 and the 6/8. So 3/4, 3/4, and 6/8. In one of the lessons, I have already explained that, indeed I did exactly when I explained the dot and the tie, I explained that the 6/8 and the 3/4, they have exactly the same identical quantity of, let's say, quavers, I should say. Let's try to use very simple examples. So one in 3/4 and one in 6/8. For example, in a 3/4, if I want to use a F, it has to be worth 3 quavers, for example, yeah? So 1.5, 1 count and a half. Obviously in it there are hidden 3 quavers, 3/8 notes, 3 half count notes, half beat notes. And I want to then write a G that is worth exactly the same identical quantity of quavers. In this case I am considering this quantity according to the time signature, according to the numerator of the time signature. This is a bar made of 3 counts, isn't it? Each of them worth 1/4. Each count worth 1 crotchet, 1/4 note. It is 1 and 2 and 3 and 1 and 2 and 3 and. In 6/8, these identical notes can definitely stay, but they will be considered in a different way, and the result will be definitely different. I can also write it in a different way. I can write the second note, the G, using the dotted crotchet that I didn't use here, because obviously here can be confusing. Here it definitely makes sense. Here we have in 6/8 very slow. We have to consider 6/8 made of 6 counts, each of them worth 1/8, 1 quaver. In the fast ones, as I explained in one of the previous lessons, the 6/8 is considered made of 2 counts. The very funny bit is that the quantity is identical. The values are the same. This is exactly like this. This is exactly like this. But the problem is that here we'll be counting 1, 2, 3, 1, 2, 3, or 1, 2, 3, 4, 5, 6. With a strong accent when I play the G. Here there is also the accent, but it's an accent due to the syncopation, let's say. Here I will do 1 and 2 and 3 and. Here I will do 1, 2, 3, 1, 2, 3, or 1, 2, 3, 4, 5, 6. The sound, it's, I could say, identical, but it's simply the concept that is different. Here we have 3 counts. Here we have 2 counts. Here 3 counts, each of them worth 1 crotchet, 1 quarter note. Here 2 counts, each of them worth 1 dotted crotchet. Here the subdivision is binary, each count divided into equal parts. Here each count divided in 3 equal identical parts. 2 counts, 3 counts. So let's play the 3/4, 1 and 2 and 3 and 1 and 2 and 3 and. Let's play the 6/8. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. In my mind, in your mind, they seem definitely something completely different. And this is the real difference in between the 3/4 and the 6/8. The quantity of notes is identical. The look of the notes, because indeed I could even write this one using the same identical dotted crotchet. I haven't done, but it's the same. And this is the difference between the 3/4 and the 6/8. And now I think that we can talk about the difference that there is in between the duplets and the triplets. I could even say that it derives from the previous example. Because indeed, the duplet occurs when you divide a count into equal parts. The triplet occurs when you divide a count in 3 equal parts. It's very clever now to use the metronome. I will write a simple bar in 4/4, writing, for example, something like middle C, 2 counts, then I do a triplet on the 3rd count, and I write a G, 1 count. Pay attention. Now the metronome on. I want to use a very low speed because you have to definitely follow me carefully. Let me see if 72. So 1 and no, even less. It's too much. 72. 1 and 2 and 3 and 8. Okay, fantastic. It's definitely needed the metronome. Now look, if I subdivide each beat, each count into equal parts, into subdivisions, it will be 1 and 2 and 3 and 4 and 1 and 2 and 3 and 4 and I can carry on. At some point, on the 3rd count, I will have to change the way I subdivide. But that's why I'm using the metronome, because now I have to divide that quantity in 3 equal parts, not in 2. It's like taking an A4 paper, dividing once in halves, and obviously the size of the half is quite big. But if I divide in 3 equal parts, the size of each third is definitely less. Okay? Imagine that you have something that is 9 centimeters. If you divide in halves, it would be 4.5 and 4.5. If you divide in 3 equal parts, it will be 3, 3, 3. This is a very important case, very important example that I'm giving you. If you divide 9 by 2, look, 9 divided by 2, you get 4.5. If you divide 9 by 3, you get 3. And this is what you have to keep in mind when you play duplets and triplets. Because we can consider the quantity, obviously we never talking this way in music. But you can consider the quantity finally in this way to help you understanding. I think that now with this very basic and simple mathematical example you understood which one is the problem, which one is the case. And now indeed, let's try to play this one. So it is 1 and 2 and 3 and a 4 and... Maybe I play a few times in loop, in this way you understand more and more. Again, 1 and 2 and 3 and a 4 and 1 and 2 and 3 and a 4 and 1 and 2 and 3 and a 4 and 1 and 2 and 3 and a 4 and... Have you noticed what I did? 3 and a 4 and 3 and a 4 and... You have to be able to obviously speed up, but this speed that you gain when you play the third count has to give you the chance anyways of playing them, giving to each of them the same identical length. Exactly as I said. Imagine that you're dividing something in 3 equal parts and each element has to be 3, 3, 3. In the duplet, imagine that it was each half was worth, so in the binary part, each half was worth, for example, like 4.5. But this is an example, it doesn't have anything to do with our speed, just to help you understanding. I hope that is a little bit more clear, the difference in between the duplets and the triplets. Obviously here is not expressed the duplet. I can express one duplet, doing for example now something like C, D, and this is an authentic duplet. Now I can play here one triplet, cheek, cheek and cheek, visible, one more duplet, and one more triplet. More than these, I think that it's impossible to explain and clarify. So you do 1 and 2 and a 3 and 4 and a, using the metronome. Look. 1 and 2 and a 3 and 4 and a 1 and 2 and a 3 and 4 and a 1 and 2 and a 3 and 4 and a. Maybe even slower. Why not? 1 and 2 and a 3 and 4 and a 1 and 2 and a 3 and 4 and a 1 and so on. Okay? So I really hope that now it's all clear to you. It's a very interesting lesson, this one. I think maybe one of the most important until now, because it's very practical, helps you really understanding how to solve from a very practical point of view all I've explained until today. Obviously, if you have any question, feel free to comment. I invite you to really to comment. Many students are commenting, are sharing their thoughts, giving me their feedback. I really hope that everybody can do the same. If it's the first time you're landing on my channel, thanks to this video, don't forget to subscribe and see you in the next one. All the best. Cheers.